I'm sure you all know that we're made from atoms, and I'm sure you also know that these atoms are made from subatomic particles, electrons, protons, and neutrons. However, what you might not know is that these subatomic particles sometimes behave as waves and sometimes as particles. Now you might be wondering, how come we don't see wave behavior from humans? You're about to find out.
Now I want you to imagine you have a box, and in this box you put a coin. Now I want you to shake this box really well. So then you don't know if the coin landed on heads or tails. Now logically you'd say that the coin landed on either heads or tails. However, according to quantum physics, the coin landed on heads and tails simultaneously.
This analogy can be used to explain the phenomenon of quantum superposition. Quantum superposition is the principle that any physical system exists as all its possible states at once. However, there is a slight fault with this analogy, which is that a coin follows the rules of classical physics, which is the study of physical systems on a macroscopic scale. For example, how tennis balls move. Whereas we are talking about quantum physics, which is the study of physical systems at an atomic scale. This phenomena is due to the wave and particle-like nature of everything. Which brings us back to why humans don't behave as waves, and that is because as momentum increases, wavelength decreases. And with such a tiny wavelength, you'll never see wave-like behavior from a macroscopic system such as humans, whereas a tiny particle such as an electron can show evidence of its dual nature. If we shoot electrons at a barrier with two narrow slits, with every electron being detected on the other side, the pattern made by the electrons on the other side is a wave-like pattern. Now block one of the slits and the pattern goes away. This shows us that each electron is choosing to go left and right simultaneously. Understanding quantum superposition is very important because it determines how electrons move through semiconductors such as silicon. By understanding how electrons are shared between atoms, we are able to control the properties of semiconductors. Combining many semiconductors in the right way allows us to make transistors on a tiny scale, millions on a single computer chip. Those chips and the spread out electrons power the computer you're using to watch this video right now. In conclusion, quantum superposition is the principle that any physical system exists as all its possible states. Quantum superposition is due to the wave and particle-like nature of everything.